Hello everyone, let's go over some rational equations to review for our test. So for the first one is we have all the denominators are factored already for us, so which is really beautiful, so we don't have to do that step. So you go down to the following step, which is to look for LCD. So for that I try to see what we have in the denominator. So I see we have x minus 5, so that's definitely going to be part of our LCD. And then we have a x plus 2 and x plus 2. So that is also going to be part of our LCD. So that means our LCD is x minus 5 and then a x plus 2. And we're going to take that and we're going to multiply it to every single term. So that way we are able to get rid of our denominator. So we have x minus 5 and x plus 2. And then one more time, I'll write it a little bit to the top so it doesn't overcrowd with the other problem. Okay, so the stuff that we have in common, we're going to cancel them out. So x minus 5, x minus 5, x plus 2, x plus 2, x minus 5, x minus 5, x plus 2, and x plus 2. And then we write down the stuff that is left over, which is x plus 2. And then let's see, and then we have another x minus 5 left over. And then let me write down the stuff that is on the numerator. So x plus 3 plus 6 and equals to 6 plus 10x. The 6 plus 10x, technically you could have factored it, but numerator stuff, it's okay if we want to leave it the way it is because we don't need the numerator for LCD, just the denominator. Then we are going to FOIL and distribute as much as we can. And then we have 6x minus 30 is equal to 6 plus 10x. All right, we combine our like terms. The x squared just remains the way it is. Then we have a 3x plus 2x minus 6x. So that, what is that? 3 plus 2 is 5. 5 plus 6 is 11x. And then we have 6 minus 30. That is going to give me a negative 24. Is equal to 6 plus 10x. Then we're going to make sure that our equation is equal to 0 because in order for us to factor, we need to have our equation is equal to 0. Okay, so 11 minus 6 is going to give us a 5. And negative 24 minus 6 is going to give us a negative 30. Is equal to a 0. So now we need to look for two things that multiplies to a negative 30 and adds up to a positive 5. We could do that using our calculator. So I'm going to go ahead, pull up my calculator. Let's see. Y equals negative 30, divide that by x, and I go to my table and I look for two numbers that's going to multiply to negative 30 and adds up to a 5. I feel like I may have made a mistake when I did the calculation, so I'm just going to double check one more time. Because I don't think there are two numbers that multiplies to negative 30 and adds up to a positive 5. So let's see, let me double check one more time. So we have x plus 2 times x plus 3, so we have x squared plus 3x plus 2x plus 3 times 2 is 6, and then we have a 6x plus minus 30 is equals to 6. Okay, so we have x squared, 3 plus 2 is 5, 5 plus 6 is 11, and then 6 minus 30 is going to give us a negative 24, minus 6, minus 6. Oh, there's the mistake, I found it. It should have been a minus 10x. So we are left over with just a positive 1. Okay, all right, crisis averted. So then we have to look for two numbers that multiplies to negative 30 and adds up to a positive 1. And those two numbers are 5 and 6. The 6 is positive, 5 is negative. So then we go on, and then we have x minus 5 is equal to 0. X minus 6 is equal to 0. So x is equals to positive 5. And x is equals to, positive 5, and then we have a negative 6. So we're going to use this item to figure out which one of them is going to give us a extraneous root. So if I use 5 in the denominator, so I could actually do this side by side with my calculator. So let's see. If I have my calculator and let me move this out of the way. So we have alpha y equal to enter, and if I do 5 plus 3 over, and then I have 5 minus 5, and then I have plus alpha y equal enter, alpha y equal, and if I do again 6 over 5 plus 2, and we're not putting the equal sign just yet because that I'll do separately. So this one gives me an error. So that right away tells me that 5 cannot be part of the solution set. But we should always take a look at our second one as well. So I'm going to do the second one now. So I'm going to do alpha y equal one more time. And then I have negative 6 plus 3 over negative 6 minus 5, and then plus alpha y equal enter, and then I have 6 over negative 6 plus 2. So that gives me this whole long decimal. So let me see if on the right hand side I also get that too. So alpha y equals 6 plus 10 times negative 6, and then in the denominator I have, okay, let's take care of the parentheses, negative 6 minus 5. And then I have a negative 6 plus 2, close parentheses, and we end up getting the same exact long running decimals with negative. So that means our only correct solution is negative 6. So if x equals 5 is an extraneous root. Okay, so let's take a look at our next question. The next one is an error analysis, so we have to take a look at what we have to figure out what the error is. I'm going to also take a look too with you. So we have, let's see, so this is a one-term rational is equal to another one-term rational. So this one technically you could cross multiply. However, when we were doing simplifying rational expression, we know that we can't just cancel out top and bottom x because we have the plus 4, so we cannot cancel out. So this right here, so can't cancel out x top and bottom because we have to consider the positive 4. So this one you could do with cross multiplication. Actually, you know what? I'll show you what it looks like with cross multiplication. LCD method would work too. If you wanted to use LCD would be x plus 4 and x minus 1 as well. But if you are using the cross multiplication method, excuse me, this is what it will look like. So let's see, I'm going to multiply x plus 4 times 3 and 2x times x minus 1. So we have 3 times x plus 4 is equals to 2x times x minus 1. So we have 3x plus 12 is equals to 2x squared minus 2x. So for this one, I would have to make sure we set it equal to 0. So minus 3x, and then minus 12 minus 12, which leads to a 2x squared minus 5x minus 12 is equal to 0. So notice how I moved everything on the right-hand side instead of the left-hand side, but we could also rewrite it as 2x squared minus 5x minus 12 is equal to 0 because our eye is used to seeing that way. So it's fine if you do it that way too. Okay, so now we have to find two number that multiplies to, let's make our table, multiplies to 2 times negative 12, so multiplies to negative 24, and adds up to a negative 5. So those two numbers, let's see, we have 2x squared, and then we have a negative 12 equals 0. I can't think of those numbers. So let's see, 2 times 2 negative 12, that's not going to work. I think 3 and negative 8 would do. Yeah, the 3 plus negative 8 does add up to a negative 5. So we have, let's see, positive 3x and then minus 8x. So let's pull out a GCF of x, which gives us a 2x plus 3, and then minus 4, which gives us 2x plus 3 again, is equals to 0. So then we have 2x plus 3, and then we have a x minus 4 is equal to 0, which lead us to having 2x plus 3 is equal to 0, so x is equal to negative 3 over 2, and then we have x minus 4 is equal to 0, so x is equal to positive 4. But when x is equal to positive 4, we will have a denominator. Actually, no, this is pretty good. We don't have any extraneous root in this one. X equals 4 is just fine because 4 plus 4 is 8, so that's not going to give us an extraneous root. So the two solution we end up having is negative 3 over 2, comma 4. All right, let's take a look at number 14. Number 14, let's see what mistakes do I have. I actually sometimes start solving it before I even go on to it. So let's see. For this one, we have, how many x's do we have? We have x to the power of 2. So we have x to the power of 2. So that's definitely needs to be it because we also have an x here. And then we have a 2 and 2. So it's going to be x squared and 2, which I could write it as 2x squared. That's my LCD. So I'm going to multiply that to every single term, but let me just rewrite the problem a little bit so I have more space. I actually did not look for the error. I will as soon as I finish solving it, because sometimes that makes my life just a little bit easier to solve it that way. So let's see, 2x squared multiplied by 2x squared multiplied by 2x squared. So that leaves me with x squared and x squared cancels out. And then 2 cancels out, one of the x cancels out, 2 cancels out. So I have, for this one, I just have one more x left over because 2x squared is equals to 2 times x times x. This one, 2 and 2 cancels out, so I am left over with just a x squared. So let's see, I have a 2 here, and then I have a 5 here, and then I have a 1 here. So let me bring down the other stuff. So this is 2, and then plus, and then times x squared. Let's see. Okay, so let's simplify what we can. We have a 2 times 2 is 4 plus 5x is equal to x squared. Same thing, we're going to set it equal to 0, which leads to a x squared minus 5x minus 4 is equal to 0, which leaves me, or I could write it as like x squared minus 5x minus 4 is equal to 0. That is x minus 5, x plus 1 is equal to 0, which leaves me with having x is equal to positive 5 and x is equals to negative 1. We don't have any extraneous root because either of them in the denominator will not give me undefined. So let's see what was the mistake in this one. The LCD was an issue, so we could say incorrect LCD. Because if the LCD was correct, we would not have this x with us. So we needed to take care of that LCD. So that was the issue. Okay. Oh, wait. I made a mistake too. This should have been a 3. Ooh. Let's see. I may need to redo the problem too. I'm rushing a little bit. I think that's where I'm making the most mistakes. So this should have been 2 times 3, 5 times x, 1 times x squared. So this is 6. Oops, my bad. Minus 5x, minus 5x, minus 6, minus 6. Okay, nonetheless, their LCD is still incorrect because they have a 6x, whereas we just have 6. So that was the incorrect LCD situation. And they also, actually no, that was the only mistake that kind of led them to make more mistake. So we could rewrite this as x squared minus 5x minus 6 is equal to 0, which leaves us with x minus 6 and x plus 1 is equal to 0. So x is equals to positive 6 and x is equals to negative 1. But neither of them will give undefined in the fraction. So we are okay with using both. Okay, let's take a look at number 15. So number 15, we have to think a little bit. Actually, no, we don't really need physics for it, but if you are looking at it, it may remind you a little bit about physics because of the circuit board. So let's see. Electrical circuits can be connected in series, one after another, or in a parallel circuits. That branch off a main line, if circuits are hooked up in parallel, the reciprocal of the total resistance in the series is found by adding the reciprocal of the resistance as shown in the accompanying diagram. So you don't even need to know the formula. This one is just mostly about substitution. They just gave you the formula and you just need to know where to substitute what. So R of t is 2.25. Okay, so let's go ahead and substitute wherever we can. So we have, let's see, 1 over x plus 1 over x plus 3 is equals to 1 over 2.25. So the LCD is going to be a little bit interesting because we don't have anything that goes with it. So we have to technically use all three of them. So 2.25, so I'm going to just write it there. And then we have our R1, we're going to use that. And then we have our R2, and we're going to use that as well. So let's see. So this is our LCD. So we have x times x plus 3, and then we have 2.25. Okay, let's do that. And I'm going to multiply that to every single term. And I'm going to leave it the way it is. I'm not even going to simplify it. It's just going to make our life easier leaving it like this. So we have x times x plus 3 times 2.25, and then we have x times x plus 3 times 2.25. Okay, the stuff that's in common, that's got to go. Okay, so that means we are left over. So the numerator, all of them is just 1. So that's not going to make or break our life, but we could write it down if we want to. Okay, then the rest of the stuff is going to come down, which is x times, no, which is x plus 3 here times 2.25. And then let's see, the other one is x times 2.25. And then we have x times x plus 3. Okay, so we have to distribute, so we have 2.25 x, and then 2.25 times 3, I do not know what that is. I need to use my calculator. 2.25 times 3 is going to give us a 6.75. Plus we have a 2.25x, which is equals to x squared plus 3x. So now we combine our like terms. 2.25x plus 2.25x, 2.25 plus 2.25 is going to give us 4.5. So we have 4.5x plus 6.75 is equals to x squared plus 3x. Okay, so now we need to set it equal to 0. So we have to subtract. 3 minus 4.5 is going to give us a 1.5 minus 4.5x minus 4.5x minus 6.75 minus 6.75, which is going to be equal to 0 is equals to x squared minus 1.5x minus 6.75. Okay, we could also rewrite this as x squared minus 1.5x minus 6.75 is equal to 0. So now I know we're kind of used to seeing when we have a whole number with like when we are factoring and stuff, but there are times when we work with decimal, and that's fine. The idea is still same when it comes to that. So we're going to look for a two number that multiplies to a negative 6.75, and we need it to add up to a negative 1.5. Okay, so let's see what we can find. This one we may need to use. Let's see if I did it correctly. I just want to make sure. Actually, we could turn the 6.75 into a fraction. That might be able to help us out a little bit. Or let me see if I could use fraction or if I could use calculator. Okay, so we have y equal, we clear it out. Let's see what were our two numbers. It was negative 6.75, negative 6.75, divide that by x, and then I take a look at my table. I just need two numbers that's going to add up to negative 1.5. I feel like, let me see, if I do negative 3.5 times 2, will that work? No. We may need to use something called a quadratic formula, but I don't know if we all remember it. I'll show it to you with the quadratic formula, but the one in the test is not going to be with quadratic formula. So let's see. A is equal to 1, B is equals to negative 1.5, C is equals to negative 6.75. So we have x is equals to negative times negative 1.5 plus, oh, gotta give you the formula first. X is equals to negative b plus or minus b squared minus 4ac, divide that by 2a. So we end up having a negative times negative 1.5 plus or minus b squared is negative 1.5 squared minus 4 times 1 times negative 6.75. This is something we learned in Algebra 1. We're going to go over it again in Algebra 2. If you recall it, it's great. If you don't, it's fine. We have not done it yet, so I'm not going to put something that requires quadratic formula on the exam for this question because we haven't done it yet. So let's see, I'm going to take care of stuff that's inside the radical, so which is negative 1.5, and then close parentheses, close parentheses square, then we have minus 4 times 1 times negative 6.75, close parentheses, which ends up giving me a negative times negative is positive 1.5 plus or minus 29.25 divided by 2. So we have square root of negative 2.25. So I'm going to do it like this. One of them is going to be with plus, and the other one is going to be with minus. So 1.5 plus 29.25 over 2. And the other one, let's see if I could turn it into a fraction math. Enter, enter. Nope, I can't. And then the other one is going to be with minus, so I hit enter. But I'm going to turn this into a minus, which is a negative number. We can't have negative number. We have to, because the question said to only look for the positive. So I'm going to say x is approximately 3.5. Okay, let's take a look at our next question. Our next question we have to find, Marcus is in a long distance, Marcus is a long distance walker. In one race, he walked 45 miles in T hours, and another race he found T.3. We have to determine the number of hours that okay, Marcus walked at an equivalent rate. Okay, equivalent rate, there we go. Determine the number of hours it took for each race. So, okay, so we have two different races. We could call them race 1 and race 2, I guess. So let's see, if they are equivalent in time, I could just set them equal to each other. 45 over t is equals to 75 over t plus 3. So we could do LCD or we could do cross multiplication. Let's do LCD for this one for fun. So we could do t times t plus 3. Going to multiply by t times t plus 3. And then here too, t times t plus 3. We cancel out t and t, cancel out t plus 3, 3 plus 3. We are left over with 45 is equals to, let's see, 75. And then let's see what we got. So over here we have a t plus 3. And over here we have just t. That leaves us with 45t plus, okay, the t and the plus sign looks a little bit similar, so we need to be mindful of that. Plus 135 is equals to 75t. We subtract 45t, subtract 45t, which is equals to 135, is equals to 75, minus 45, which is equals to 830t. 135 divided by 30. T is equals to 4.5. So that means this one took, we need to find it. Marcus determine the number of hours that each of the two races took. So we can say race 1, race 2. Okay, so race 1, it took 45. This one is minutes. And then let's see, then race 2 took us 45 plus 3, which is going to be equal to, oh, these are in, time is an hour, so 45 plus 3, which is 48. Okay. No, I'm counting them all wrong. It's 4.5. What's wrong with me? This is 4.5 hours. This is 4.5 plus 3, which is equals to 7.5 hours. Okay, this is done. All right, let's take a look at our last word problem. So this one, go ahead, take a time to read. And they wanted to know initial amount for this one. So initial amount meaning like when the value of t is equal to 0. So I'm going to do n of 0 is equals to 0 plus 1 over 0 plus 5 plus 18 over 0 squared plus 8 times 0 plus 15, so which is equal to 1 over 5 plus 18 over 15. So if we use our calculator for this one, which we should to make our life just a little bit easier, a little bit. Let's see, we have, if we clear it, alpha y equal, we have a 1 over 5, and then we have plus alpha y equal, enter 18 over 15, which is a 1.4. Okay, let's take a look at the next one. We have a of 0, which is equals to 9 over 0 plus 3, and then we have 9 over 3, which is equals to 3. And for justification, the work is enough, and then we can also say initial amount where t is equal to 0. Then the question is asking where we are going to find out when both of them are exactly equal to each other. So we set the equation equal to each other. So we have to say n of t is equals to a of t. And I need more space for this one, so I'm going to make it full screen. And then we have a t plus 1 over t plus 5 plus 18 over t squared plus 8t plus 15 is equal to a 9 over t plus 3, which we have to factor it. We have t plus 1 over t plus 5 plus 18 over t plus 3, t plus 5 is equals to 9 over t plus 3. So the means for our LCD is going to be equal to, trying to rush a little bit, t plus 5, and then we have t plus 3. Then we end up having a t plus 5 here and t plus 3. And then we're going to multiply that to every single time. T plus 5 and t plus 3. T plus 5 and t plus 3. And t plus 5 and t plus 3. Okay, I am going to stop because the bell rang, and then if you have any questions, we could bring it to class.